In this class, let us say something about colloids. Colloids, this chapter, is another part of your surface chemistry. Now, let us see what are colloids. In 1869, a scientist by name Graham Thomas had performed one simple experiment of diffusion by taking number of solutions. That is, he took gum solution or glue in a parchment paper bag or membrane bag, sugar solution, milk, sodium chloride solution. Like, he took number of solutions and placed them separately in membrane bags, then hanged in a trough containing flowing water. This is the experiment performed by Graham Thomas. He observed, in case of some systems, some solutions or some bags, the particles, dissolved particles, diffused from the membrane bag. In some substances, there was no such diffusion. See, in the case of glue, particles did not diffuse, whereas in the case of sugar, diffused, sodium chloride diffused, milk not diffused. This much he did and not explained anything. After few years, it was Rutherford and other performed the same experiment. Then they even name or word colloids. Then what are colloids? See, there are some systems in which particles can be viewed, observed through our naked eyes. In certain systems, the particles can be seen through our naked eyes. Such substances or systems are known as suspensionoids. They are known as suspensionoids. In the case of this type of systems, particles can be seen through our naked eyes. There are some substances in which particles cannot be seen. Particles are invisible even under ultra microscope. Such systems are said to be true solutions or crystalloids. These are known as suspensionoids or coarse suspension. Okay. In the case of suspensionoids, particles can be seen through our naked eyes. Here, particles are invisible, cannot be seen even under ultra microscope. And there are some substances in which the particles, some systems, particles cannot be seen through our naked eyes or invisible to the naked eyes, but visible under ultra microscope. So there is one system which lies between these two types of systems. Here particles are invisible even under ultra microscope. Here particles are visible even to the naked eyes. So there is a system in between these two types in which particles present can be seen only under ultra microscope but not to the naked eyes, but not through the naked eyes. Such systems are named as colloids, was given by Rutherford. So colloids are the systems lies in between crystalloids or true solution and suspensionoids or coarse suspension. See, in the case of colloids, particle size varies from 1 nanometer to 1000 nanometer. In case of colloids, particle size varies from 1 nanometer to 1000 nanometer. Okay. In the case of true solution, where particles are invisible even under ultra microscope. Here particle size is below 1 nanometer. 1 nanometer means 10 to the power of minus 9 meter. Below 10 to the power of minus 9 meter dimension, systems are known as true solutions or crystalloids. Here particle size is very, very small. Okay. In this case, particle size is greater than 1000 nanometer. So definition of colloids is this: colloids are the systems in which particle size varies from 1 nanometer to 1000 nanometer, 10 to the power of minus 6 to 10 to the power of minus 9 meter. Okay, this is actual definition. Particle systems in which particle size varies from 1 nanometer to 1000 nanometer, known as colloids. They are in between crystalloids and suspensionoids. Okay. One thing you should keep it in mind: any system can be brought into colloidal state. Any system can be brought into colloidal state. If system is in the crystalloid state, by increasing the particle size, that is through aggregation, association, you can bring true solution into colloidal state. Similarly, from suspensionoids, you can get colloids. That is, by in case of suspensionoids, particle size is bigger than colloidal particles. So by breaking the particles of suspensionoids, you can bring suspensionoid into colloids or colloidal state. Now we shall see the differences between these three. Simply I will give one example for each. Suspensionoids. Mud water. In mud water we can view mud particles even through our naked eyes. Here colloids, glue, milk, etc. Later I will give other examples. True solution of sodium chloride, solution of urea, solution of sucrose, etc. They are considered as true solutions in which particles cannot be viewed even under ultra microscope. See the differences between these three types of systems. First one, particle size. See, in the case of suspensionoids, particle size is greater than 1000 nanometer. Whereas here it is 1 nanometer to 1000 nanometer. Here less than 1 nanometer. So on the basis of size, we can differentiate these three systems. Next one, visibility. See here, particles can be observed through our naked eyes. Here, particles can be observed only under ultra microscope but not through our naked eyes. Here, particles cannot be seen even under ultra microscope. So this is one difference. So regarding visibility, this is regarding size. This is one, visibility. Next one, regarding movement of particles in the system. Here, movement of particles in the system is slow. Movement of particles in the system is slow because particles are bigger in size. Here, movement of particles is fast, rapid. Fast movement of particles exists in the case of true solution. Whereas here, in between these two, moderate speed. That is. Next bit is action of light on the system. That is light action. On passing powerful beam of light through these three types of systems, what happens? See, in this case, in the case of suspensionoids, scattering of light takes place. In the case of suspensionoids, scattering of light takes place. Here also scattering takes place. Here there is no scattering, simply transmission takes place because particle size is very, very small. Okay. So, these are few important differences between suspensionoids, colloids and true solutions. Next bit is, now let us consider only the colloidal systems. You know, colloidal systems are those systems in which particle size varies from 1 nanometer to 1000 nanometer. Particles are invisible to the naked eyes but visible under ultra microscope. These 2 points are very, very important regarding colloids. See, colloidal systems are generally made up of 3 components, 3 substances, 3 parts. One is known as dispersed phase. Dispersed phase. Dispersed phase supposed to be the colloidal particles which have dimension ranging from 1 nanometer to 1000 nanometer. Dispersed phase. Next one, dispersion medium. Dispersion medium, generally solvent. Dispersion medium is that substance in which colloidal particles are distributed, dispersed. Say, air is a colloidal system. Air is a colloidal system in which fine particles of dust are dispersed in a gas phase. Here gas is medium. Fine particles, dust particles are phase, colloidal particles. ಆ ಡಸ್ಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ಗೆಲ್ಲ ಕೊಲಾಯ್ಡಲ್ ಡೈಮೆನ್ಷನ್ ಇರುತ್ತೆ, ಬರೀ ಕಣ್ಣು ಕಾಣಲ್ಲ. On the other hand, can be seen under ultra microscope. ಅದು ಗ್ಯಾಸ್ ಫೇಸ್ನಲ್ಲಿ ಡಿಸ್ಪರ್ಸ್ ಆಗಿದೆ. ದಟ್ ಗ್ಯಾಸ್ ಈಸ್ ಮೀಡಿಯಮ್, particles are phase. There is another substance in the system that is known as stabilizing agent. Generally, colloidal systems are composed of three components or parts: dispersed phase, dispersion medium, stabilizing agent. The stabilizing agent increases the stability of the colloidal system. It helps to bind these two substances together, medium and phase. Stabilizing agent keeps the medium and phase together in the system. I'll give an example. Milk is a colloidal system. Best example, milk. Milk is a colloidal system in which dispersed phase is fat. Fat is the dispersed phase. Fine particles of liquid fat are dispersed. In medium is water. So milk is a colloidal system made up of fine particles of fat having colloidal dimension and water, which is medium. These two are together. To keep these two together, there is another substance present in the milk that is known as stabilizing agent or stabilizer, that is none other than a protein known as casein. Casein, which is a protein present in milk, acts as stabilizing agent. It keeps water and fat particles together in the system. Okay, so dispersed phase, dispersion medium and stabilizing agent. Now, if it's generally colloidal systems are known as salts. Colloidal systems are called as salts. If a colloidal system is prepared by making use of water as a medium, water is present as medium, dispersion medium, then that colloidal system is known as aquasol or hydrosol. Hydrosol means it is a colloidal system in which water is present as a medium, dispersion medium. On the other hand, if dispersion medium or solvent is alcohol, then such systems are known as alkosols. Alkosols are those colloidal systems in which alcohol is acting as dispersion medium, in which salt particles are dispersed. If benzene is used as solvent or medium, then it is known as benzosol. Benzosol, like that. Next, classification of colloidal systems. See, colloidal systems are classified in three ways. In three different ways they are classified. In one type of classification based on physical states of dispersed phase and dispersion medium. One type of classification based on physical states of dispersed phase and dispersion medium. Second one, classification based on affinity between dispersed phase and dispersion medium. Nature between dispersed phase and dispersion medium. Another type based on the nature of dispersed phases. In the next class, I will discuss about that.